testing environment, you wouldn't suffer from that. And so many things that you can imagine, so many scenarios. Now, and so many scenarios that you can imagine, beyond even doing harm, up to even damaging your what? Damaging the image of your organization, such as things like spelling, things, etc., just all the human mistakes. So here, for example, here the company that I work from, we first test things. We have a team, a whole team that works on testing. They first test things, and when things they are okay, or if the things have errors, they send them back to our development team. We fix those errors and send back them to testing. And when this whole thing is ready, the testers have said that it is fine, then we let it proceed into into the production. So that process is what we call sandboxing. Members, I hope you're getting the concept. So the essential for testing new applications, analyzing malware. It is essential for testing new applications, analyzing the malware, and mitigating the zero-day threats. Okay, so sometimes maybe we can be having people with different intentions to the organization. So if we can test this code into uh, testing environment before it proceeds to production, we can maybe detect these malwares or these quite hidden people before something goes outside there. So you can imagine as many mistakes as possible that can happen if we don't test our code and we just let it proceed to production. So I hope we are getting a picture. Members, are you understanding things or I'm just being Chinese? Someone should unmute and tell me that we are relating.
Yes, sir.
You're getting the things, eh? Okay, good. Hope so.
Yes, yes, yes. Good.
All right, that's good if you understand the things. So let's proceed. So the definition and concept of sandboxing. So we shall have what we call sandbox environment. So let's look at some useful definitions that we use for sandboxing. They're the thing that we are training you so that when you're going to become real world developers, you should introduce these things to your organizations or when you make your own companies, because these are the good things. Otherwise, if you don't learn these kind of topics, what happens is you'll end up learning it hard way when you have already doing mistakes first. Okay, but if you are prepared in this way, it helps you not to do what, not to do this kind of mistakes when you're in real world. All right, so sandboxing environment, or what we are calling the testing environment. It is an isolated virtual space where programs run without affecting the host. As I said, I told you that we shall have production and testing. Me, I was calling it testing. Okay, so the environment that we use for testing things can be a virtual computer, it can be a separate hosting space, it can be anything, but that is not going to tamper with the real production. Okay, but it is having almost all the specifications of the real production. That environment that you're going to use to play with, where you're going to have the data that you're going to be playing with, is what we call the sandbox environment. So if we ask you an example of sandbox environment, you should be able to tell in your own way how you've understood it. Or if someone talks about sandbox environment, you should be able to understand what is meant. The place where you use to test things before we push them into the production. So I hope you've understood that. Uses the metaphor of child's sandbox, a confined area for safe experimentation. It is a lab where we first do experiment from before we take things outside into production or into use. So this sandbox environment, it prevents unwanted changes to files, networks, or system resources. So if someone had changed something, let's say that we are working with Centenary Bank and we're developing system of Centenary Bank. Then we are at maybe we are 50 developers working for Centenary Bank and we are working only on the maybe the appearance of Centenary Bank mobile application. So we all know colors of Centenary Bank: blue, yellow, white. Okay. So maybe one developer start putting their funny colors. I think red is also part of Centenary Bank. I think it's blue, yellow, red, and white. Yeah. So another developer start putting starts putting things like red, yellow, green, purple, all of them in that application. So he's doing things that is not consistent with our brand of Centenary Bank. So how can we catch this mistake before it proceeds to our clients? Because if this kind of mistake proceeds to our client, it will be damaging our brand. We shall be like people who don't know what they actually need. Okay, so to do this, we have to put this code into a sandbox. So all our managers, all the people who are responsible for testing, or all people who have mastered the branding of our bank, Centenary Bank, will first review in this testing environment and make sure that okay, everything is fine. If there is any mistake, someone has added funny colors, as I've told you, they send it back to the team. Please, these are our colors. Can you change them to suit these colors? They can do it even as many times as possible, even 20 times, even 50 times, and make sure that everything is up to note and is agreed upon while still in sandboxing. And when everything is perfect, they let it proceed into a production environment. That is the whole point, not to push things directly to the production and then clients start using, and then when the client complain, that's when you realize that mistake. That's not how things are done. So that's the whole point of sandboxing. Why do we need to know this, or why do we need to implement sandboxing in a thing that we shall be doing? It's risk mitigation. It contains the potential threats before they compromise the critical systems. You see, the examples that I'm using things like bank. Those are critical systems. Even other systems that involve money. Let's say there's a platform like Jumia, platform like Sequoia, etc. Those systems, they are critical. If you do a mistake, people will lose money, people will lose data, people will lose records. Okay, so if something is critical, first make sure that it is error free before it proceeds into what? Not even error free, but has as minimal error as possible, if possible, error free before it proceeds into what? Into production. So testing and development uh, it helps to validate new codes or updates before they safely uh, shipped into live uh, environment, what we call production environment. Malware analysis. Detonate and study suspicious files to understand the behavior and development and develop what? Countermeasures. Okay, so we can do malware analysis and look at the files, how they are changing while they're still in what? Or how they're behaving while they're still in while they're still in what? In testing environment. Okay, and if they have a problem, we can learn how to fix this problem and how to fix this problem while still in what? In a testing environment. And it provides the proactive protection against previously unknown vulnerabilities. So when we test this thing while still in a testing environment or in a sandbox environment, it helps us to know and detect the unknown vulnerabilities. If you don't test your application and you just push it, if you don't test your system and you just push it to the users, the users may get even an error and they don't tell you. Okay? Maybe because they fear you or because they think that you'll do nothing or they have even no way to contact you or they don't even care. Okay? But if you first deploy this way of this approach of of architecture, or I mean this sandbox way of doing things, you'll know even your errors before they proceed to the customer. If you can't fix these errors, still you'd be at least knowing where you can click and where you cannot click, and you shape your application while you know its strength and weakness. So that's an advantage of sandboxing. So what is virtualization? So when it comes to sandboxing, we have very important things that we may look at. Uh, we have what we call virtualization. So it's an abstraction of hardware resources to create virtual machines or containers. I believe maybe some of us have heard what we call virtualization. Virtualization is the ability of having, for example, let's talk in terms of computer, of having more than one computer on a what? On, of having more than one computer on one computer. So with virtualization, we have softwares that we can install on a computer, and then it gives you ability to create multiple instances of other computers on that very computer, whereby a computer can have its own operating system. Let's say that I have Windows, but I need to test Ubuntu things or maybe Linux things. What I can do what we call a virtual machine. So with virtual machine, it will create for me another computer inside my computer that will have even its own what? That will have its own operating system. So I can install uh, that another operating system on this very computer, and I can operate it totally at a different computer on the laptop on the same platform. You can move it. So that's what we call virtualization. Go and search about virtualization. So I have containerization, what we call containers. Containers give the ability to create a, a, a box where you can deploy things into that box, and they'll not affect anything outside that box, but they'll be within that box. So that is containerization. For containerization, we don't need to implement. It does not need an operating system. But for the virtual machine, it will need a what? An operating system that is totally independent. For container, it will be some kind of a box which will have everything, every copy in some kind of folder, and can perform anything in any operating system. that is container. So go and search about virtualization, read about virtual machines, and read about containers, and so you can know those softwares also. Then you have isolation, uh, it's restricting programs access to system resources outside the sandbox. So the ability for us to restrict the access of system resources that are out of our sandbox environment is what we call isolation. So access control, it rules that, these are rules that govern what resources a sandbox program can access. So that thing is what we call access control. Okay, the rules that govern the sandbox. So you can say, okay, as long as maybe my sandbox does not need maybe a microphone, so you can decide that a resource like microphone should not be accessed by the sandbox environment. So that's what we call access control. And evasion techniques. So the methods to prevent malware from detecting bypass sandbox environment. So there are some techniques that we might need to deploy to avoid something not to be seen in the sandbox environment, but it is seen in the production environment. So those techniques that we use to avoid that kind of scenario are what we call an evasion technique. So environment emulation is replicating an operating system or hardware features with a controlled setting. So as I said that your environment for testing should at least or should look as should look very much like that of production. So that process of making sure that your environment is looking much more like a production environment is what we call environment emulation. So virtual machines based on sandboxing, you can decide that instead of buying two computers, one computer for testing, another computer for production. Or in case of buying two servers, one server for testing, another server for production, because it can be costly. You can decide to do what you call virtual machines. So since you have limited resources, you can install another computer on your computer by the process called virtualization. Okay, so the virtual machine, we can implement sandboxing based on virtual machine. That is one way, and in this way, we use full virtualization to emulate a complete hardware environment. So you can decide to just let me create another computer on this computer, and then this computer that I've created, it's where I'll be putting my what, or it will be testing my things that I don't want that before they proceed into the environment. So that process called it virtual machine based sandboxing. It offers high level of isolation and ideal for running untrusted applications. By the way, sandboxing, I've looked it in just one way of coding. We can still do sandboxing with softwares. Let's say that you use antiviruses at your organization. So you can decide first, test those software that you're going to use at your organization before you use them actually in the organization. So when you're testing a software, you can decide to put it in a sandbox environment. Make sure this software does not have it's not going to manipulate your company, your organization things. Make sure this software is totally not harmful to us, other than just getting a software from wherever you've got it and you put it to your organization. Some of these software, they can come with viruses or they can come with bad intentions. So what to do? First do these things in sandbox. Okay? Do them if a software does not meet the standards or that has a lot of weakness, does not meet the standards of your organization, get another alternative software. Okay? Before, let's say that you bought a software and this software is deleting your data. It is corrupted. It has malicious code. So you put on a sandbox environment, it does those kind of things. So you'll be lucky that it has done it on a testing environment. But if you just put it directly to a production environment, maybe to organization computers or server or something, what will happen? It will go ahead and mess up with the video or production data, and it will cost you. Either it will cost you image, or it will cost you money, or it will cost you resources in order to come up to the previous state that you were in. So what's the best way to do things? Create a virtual machine, or buy another machine, or buy another platform where you can first test these things before you actually start using them. As I said, before I've been looking at the code only, but I've also said that you can also do the same when you want to start making use of new software. So examples, Windows Sandbox, we have what we call VMware and Virtual Box. So go and search about VMware. It's a very popular software and it is for free. You guys, I hope you're noting somewhere. So VMware, it will help you to create another computer on your computer. Try it out. You see that you can have many computers on your computer. So detailed explanation for this, the guest operating system operates within a virtual machine, ensuring that any malicious activity is confined and can be easily reset. So with virtual machine, you can change operating systems at any time. But otherwise, if you do these things to production, you know the cost of changing an operating system, you know. So for the virtual machine, you can reset an operating system very easily. All right. And the error that happens within the virtual machine to remain the virtual machine. We have another technique called container based. The other one was virtual machine based. This one's called container based sandboxing. It utilizes the lightweight virtualization where the application runs in an isolated containers or what I called boxes, sharing the hosting kernel or sharing the hosting operating system. So the other one for virtual machine here, the difference is virtual machine, you could each container or each box could have its own operating system. Okay, but in this case, for containers, you'll have the same operating system, but everything that you do it will be isolated in that particular container, but while using the same operating system. So it is more resource efficient than full virtual machine while providing separation. So for this one, you don't need another operating system or what. So you just know that it's not going to use too much power of your computer. Okay, so it will be this is going to use the same operating system. Okay, so example of software that provides containerization. We have what we call Docker. Let's search about Docker. It's a very popular software, free. And another one is called Kubernetes container. So containers isolate applications and their dependencies, okay, ensuring consistency across different environments with minimal overhead or with minimal resource usage. So operating system level sandboxing, Okay, implements isolation using operating system features. For example, namespaces, namecomp, and app more or Linux. So for this one, it restricts processes from accessing sensitive parts of the system and and the operating system level sandboxes, it enforces restrict limits on system calls and file access, and it operates on a granular security mechanism without full virtualization. So we have seen three. This one was called virtual machine, or you have to create another machine on a new machine. This one container, just put a box on your computer. And then this one's called operating system. Here, level sandboxing. Here you're just limiting what a system should access. I mean, what uh, things that system should access and not access. So application level, application level sandboxing, it focuses on what? Isolating specific application rather than entire operating system. So in this, you can as well limit what applications should be accessed. Okay, and often built into softwares restrict in access of local services. And here we can use examples of Google Chrome. For example, Firefox. Those one can provide a sandbox so you can work in specific folders. Java applets and mobile application restrictions in iOS and Android. So, by the way, you can do even sandbox on, for example, an application. Like in Android, you can say, let this WhatsApp application not access my camera. That is all before until I first see how it works. That is also one way of sandboxing. Let the WhatsApp not access my camera, don't access my microphone until I first see how it behaves. That is sandboxing. You're already sandboxing, but based on the what? On the application, right? So when you allow WhatsApp not to access me, that now you're putting it in production. You can think beyond that, okay? So how sandboxing work? I also believe you have seen that kind of thing in browsers. When something wants to access your location, they first say allow it. When something wants to start sending your application, a website wants to start sending your application, they say allow this website to send the application, etc. Right? Now, sandboxing are the core mechanism of sandboxing. It mimics the hardware, operating system, and network configuration to provide realistic testing conditions. Okay, and isolation restriction enforces boundaries that prevent code from what? From accessing external resources. Monitoring and logging, I believe this is normal English, you are understanding. Tracks the system calls, file modification, and network activities for analysis. That's what you call monitoring. You may decide to monitor, okay, what everything that is being done in your sandbox. So reset and clean up. So the sandbox environment cleared, it's cleared after each session to any, to remove any residue changes. So all the residues that remain in the sandbox, you can do it. You can decide to clear it before you put another application, something like that. So these are the core concepts that we use when we do sandboxing. So the detailed explanation here, the environment evaluation and virtualization. So virtual machines replicate a complete hardware systems, including CPU, memory, and storage, and containers package application with their dependencies for the consistent behavior. So the emulation ensures the test environment in real world is mirrored. Okay, and here These techniques allow researchers and developers to observe how code interacts with the system components without risking the permanent changes of system in the production. So access control limit. What a sandbox program can do, it restricts the file system, you can restrict the file system, you can restrict the network communication and hardware interactions. So let's look at the evasion techniques. So we can look at the advanced malware may detect sandbox environment and alter its behavior. So evasion strategies include hiding the virtual machine signatures. You can hide the signatures of virtual machine, randomizing the system responses, and employing timing checks. Detailed explanation for this is that this technique, such as intercepting the system queries and simulating real user interactions, help to prevent the malware from sensing the sandbox and ensuring accurate behavior analysis. So I was also doing the sandbox testing. Make sure that at least the something that you're testing, you shouldn't detect that you're actually testing it, or it shouldn't detect that it's actually the sandbox uh, environment. So here, an example is testing and trusted code. So a developer tests a new application code within a virtual machine to verify the functionality and the identity of identifying the what? Identifying the bugs. Okay, and another example is running potentially and unstable code. This one I've already explained it. Like you have to first test the sandbox, and I've explained what's meant by sandbox environment. So you can make sure that what the application is meant to do is doing it, and also the environment. I mean, identifying the mistakes of the bugs. So running a potentially unstable code update in Windows Sandbox to ensure that it does not affect the production environment. So the detailed explanation to this is this approach allows interactive testing and debugging in a safe environment, reducing the risk where deployment. The risk before what? Before the deployment. So practical example is malware analysis. Security researchers use detect malware sandbox, e.g., AnyRun, CrowdStrike, Falcon Sandbox to donate, to detonate and observe the suspicious files. So what are the benefits of sandboxing? So for enhanced security, it isolates harmful code, protecting the host system from the damage. So this one you can tell, okay? So it helps safeguard, safe testing ground, allow allows thorough testing of new applications and updates. Proactive threat detection, it helps you to know things that can threat your application or your organization before they actually do the malicious damage to your actual production code. So actionable intelligence, and here are the challenges and limitations of sandboxing. What sandboxing may not be able to do. Performance overhead. Virtualization can consume significant resources, impacting the performance. For example, if you have a computer that has 4 GB RAM and uh, you're already using like let's say uh, 80% of that RAM, okay, then you install another computer on that same resources. You create a virtual machine on that 4 GB RAM. So what do you think is going to happen? It's also going to share the remaining percentage. So because of that, it means that your resources are going to be limited. At the end of the day, you may not get the exact same results, okay, as how a computer would have performed when it had only a single operating system. So that's what you call performance overhead. So inversion techniques. So some systems can know that you're actually testing them in the sandbox and they hide their behaviors. Okay, so when you put it in a real production, it starts showing what? It starts showing its true colors. So that's what you call evasion techniques. So some people can use evasion techniques and then you test the software. Copy it knows that you're testing it. It has its bad behaviors. Okay. Boom. When you put it to production, now it starts showing its bad behaviors. All right. And also complexity. Setting up the sandbox, of course, it is a little bit complex compared to publishing directly according to production. It is not that much complex, but it is costly and complex. So you need two computers at least, or you need two virtual machines. So compared to what you've been doing without testing, this one becomes a little bit more complex. So how about we call false positives and false negatives? So you may fail to classify which one is true error and which one is not true error because the environments are not exactly the same. So best practices here is to ensure that complete separation from production and testing environment or sandbox environment. Make sure that at least you have two computers, one for testing, one for production. That's a good practice. You can do same computers, but the better is share the servers, have two servers, one server for production and one for testing. Get it? So things don't mix up. Okay. Regular updates, keep the sandbox software and monitoring tools to current counter new session techniques. So make sure that your environment for testing is always updated because you may forget about it, okay, and be focusing on the production. So integration with security stacks, so there are some softwares that are best for testing or for sandbox. So make use of those softwares, documentation and logging. You should learn how to, you should adopt a logging. Like every operation that is being done, save it somewhere so it can follow up properly. And user training, make sure that you train the users. And also, that's a good practice also. So real world implementation of sandbox implementation and tools. So I have Windows Sandbox integrated with Windows 10 and Windows 11 and trusted application. So Windows 11 comes with the sandbox itself. If you don't trust an application, you can run it in a sandbox. So go and search how you can implement Windows Sandbox. It comes with your Windows 11 and Windows 10 if you have it. So another software that we use, we have Docker and Kubernetes. These are widely used software that we use for what? For containerization. Browser sandboxing. Modern browsers can isolate web pages, okay, and plugins. All right. So, in summary, sandboxing is an essential component of modern cyber security. If you want that you're a modern cyber security person, then you have to know about sandboxing and you should be practicing sandboxing. It enables self-testing, effective malware analysis, and robust defense against unknown Great. So I can receive, let me first finish this, then I can receive your question and answers. So how can sandboxing be integrated into your system development and security workflows? So I'm going to get um, any of you to answer this. You just give me one scenario, how you can, out of all the scenarios I've said, I want you to give me your own scenario or your own way, how you think about this. How can you implement sandboxing either in the system that you're already doing or in any way that you can imagine? I want to see your creativity. That's a question for you. One will be for gentlemen, another will be for ladies. And I'd like another person. Yes, Charlie. Charlie, I don't know. Kayla, sorry. Kayla, please answer the first question. Be free and tell us how you think you can deploy them.
I hope
Good
you can
morning.
hear me.
Yeah, you're
Good
breaking, but we
morning.
can hear you. Good morning.
Okay, I want to answer that question to the best of my ability because at the place where I did the internship, one of the first things they taught us was how to use Docker and a bit of that Kuba something. I don't know how to pronounce it properly. But I think how you can apply it, like let's say you correct me if I'm wrong, but from what I saw how we were doing it there, you would create different containers for the different, let me say, components of the application so that when you make changes, the change you make to one component, let me say if there's an issue there, it doesn't affect the entire application as a whole. I think that's it.
Thank you so much, Kayla. You can keep your microphone open. So which system are you using? Which system were they developing? Which software?
It was Crane Cloud.
It was a what?
So they were developing like Crane Cloud there at Macquarie University. So they were developing like they developed like reactive applications, something like that. I really also didn't understand it properly because I'm not really a programmer. So that was my first interaction with like real coding.
Yeah, okay. All right, thank you for your contribution. Yeah, thank you for your contribution. So as she has said, um, I had to use Docker to separate things, and Docker is Docker does what? Uh, Docker helps you to do things in different containers. Okay, so she has given us an example of containers. Thank you so much. So it means that you can now relate. Thank you so much, Kayla, for your contribution. Yes, Seruguma.
Yes. Good morning, everyone.
Good morning, sir.
I hope you can hear me.
Loud and clear.
Yes. So personally, I used sandboxing without knowing at first because I when I signed up for CASA and so that I could use it on some application I was developing, I was starting it with a sandbox with the sandboxing. Should I call it a technique or so I could perform different operations on the application and change various files. But then when I could go and start that application using VS Code at the same time, I wasn't seeing the changes I was making in the cursor. So I was confused at first. But then I realized that the changes you make when you're performing that sandboxing, they don't affect the entire system. So that's how I learned it, and that's how I used it by mistake. And yeah.
All right, you used it by mistake. All right, thank you so much that you can relate. So, before you close your microphone, so now do you realize the advantage of sandboxing?